Well, good morning. Welcome to the last day of TechEd, and thanks for coming. This is an early morning session, so I appreciate you guys being here early. My name is Madan Armugam. I'm a program manager in SQL Server in Microsoft, and I have with me Guy Bowerman. He's also a program manager in SQL Server. You saw the rotating slides. We both work on the SQL Server infrastructure technology, specifically SQL operating system and memory management and anything related to interaction with the Windows Server operating system or a virtualization layer. So we are excited to be here. The topic of the day obviously is to talk about SQL Server 2012 as it applies to a private cloud environment. We're going to talk about different capabilities in SQL Server 2012 that you can use in a private cloud environment. And I'll let you know that some of the content would be not just 200 level. I know the session is a 200 level session, but we will show some demos and some 200 plus content. Hopefully that's useful for you. So without further ado, really the goal of this session, what we hope you'll get out of this session is a deep dive into some of the SQL Server 2012 capabilities and how it would apply in a private cloud environment. And this is private cloud, whether you're running VMware or Hyper-V, a lot of the SQL Server features should apply. Obviously, the demos will show on Hyper-V, but you should take the best practices as something that you can apply in a VMware environment as well. And you'll also find out these best practices that that we'll share with you. This is with interaction with customers for about a year since we've been doing the TAP program with SQL Server customers, and also our own experience in putting together the appliance solution. We have a Microsoft Private Cloud database appliance solution that SQL Server 2012 is being built on, and there was a lot of learnings that we got, and I wanted you guys to take that learning home as well. And it was built on virtualization environment, so it should directly apply to you. And last but not the least, the common question that we get from everyone is licensing. Hey, SQL Server 2012 licensing changed again. What does that mean for me? I'm running in VMware or I have my own private cloud. So hopefully, you'll be able to kind of get some information here. We'll have references to a lot of this information in this deck, in the deck that you'll be able to get access to. We'll also hang out after the session. Feel free to come back to us and ask questions, and we'll take it from there. All right. So before we kind of do a dive into SQL Server capabilities, I thought it would be useful to kind of set some context on the terminology we will use, right? Because the terminologies are all over the map. People talk about private cloud, IaaS. So I thought it would be useful for us to kind of set context and be on the same page, if you will. So essentially, if you look at this graph, it's pretty simple. There are two dimensions. The way we like to think about cloud or the journey to the cloud, if you will, regardless of where you are at. There is two dimensions. On the lower axis is control. You are incrementally giving up control or gaining control. So you're moving back and forth in this axis. And then cost, right? The cost control is the trade-off. The more control you have, the higher the cost, because you have more flexibility. You get to say what happens in your environment. And the more you are willing to give up control, the lower the cost, because you end up running in a shared environment like a public cloud, right? So if you plot the spectrum, you'll see all the way from a physical IT managed environment, you're running on raw iron, to a virtualized environment, which is your next step. You're essentially abstracting away your box, physical environment details. And then you're moving to an infrastructure as a service where there is a service phenomenon. It's not only virtualized, but there is also an aspect of it being a service. And then you can move to platform as a service, which you all know about, where the focus is just on the application. You don't have to worry about the server behind it, the hardware behind it. It's an auto-managed service. And then the ultimatum is obviously software as a service. Each of you are likely working on software products, and you'll be able to just deliver and focus on the service and innovate on the service as opposed to worrying about tweaking a database or configuring for HA. And you can see as you go through this continuum, obviously, at software as a service, you're giving up a lot of control, so you don't have a whole lot of flexibility. But obviously, it's a shared environment and it's extremely cost-effective, and vice versa, right? If you were to go down that continuum the opposite direction, you'll gain control, and you'll incur cost. Now, this doesn't say one is better than the other, right? It totally depends on what you want in your environment, right? Maybe you want control for certain applications, maybe you don't. And so what we would like to think about is from a Microsoft point of view, if you were to plot this journey, we would like to offer solutions in each one of these spectrums, if you will. And this is kind of the textbook definition of private cloud. When we talk about private cloud, the notion is that this is an environment that your organization solely controls. And this would mean that either you have it on premises, you have a bunch of hardware, you've created a private cloud, you have SQL Server running in it, you either have VMware or Hyper-V, and a bunch of other applications as well, right? Or you could do it another way. You still have control, but you have third parties, either like Rackspace or maybe some other provider who runs your dedicated hardware on your behalf, and you are paying them certain charges, if you will. And both are considered private cloud. If you are running it on premises, it's classic private cloud. If you run it off premises, managed by a certain vendor, it's called as the hosted private cloud. Somebody else is hosting for you. It is your dedicated environment, but somebody else is taking care of the management. So with that context, if you plot the same graph with the SQL Server continuum, right? This is how we would like to think about it when we are making decisions about investing in a certain product. Essentially, you got these 4 dimensions. You've got the traditional SQL Server running in a physical machine, for the last 20-something years that you all know about this, right? Obviously, the value proposition here is you have full control from hardware, software. You get to choose, the size of the deployment, the fine tuning, the performance, and this is the world that largely that we exist today. And if you think about the journey to the cloud, you're seeing a lot of customers and companies like Microsoft investing in capabilities to gain more economies of the cloud scale, if you will. So the next point in the journey, and this is already happening, right? The SQL Server private cloud, which is running in a virtualized machine. Just 2-3 years ago, I remember there were still questions that were asked about, hey, SQL Server is a database. Can you run in a virtual machine? What kind of performance hit would you take, or what kind of changes would I have to make in my application? In the last couple of years, we've seen that customers have gone past that concern, and now we are seeing a lot of SQL Server databases getting virtualized. An interesting stat would be SQL Server is the most virtualized database in the planet, and that likely the reason is probably because SQL Server is also the most popular database in the planet in terms of units. So and we get virtualized much more than any other database. So there is a lot of momentum here. So I want to pause here and ask a question. So how many of you are actually using SQL Server 2012 already in your environment? All right. So it's been just about 3 months. So hopefully, you'll learn a bit more about, what capabilities, and you can try it out. And how many of you have SQL Server databases already virtualized? Wow. So this is definitely a lot of change in the last couple of years. So almost 70-80% of you are running it virtualized. So I would, so you could see, there's a lot of momentum towards this direction. If you think about the next click stop in terms of you give up a little bit more control at the expense of gaining more cost, is the SQL Server running in a Windows Azure virtual machine. I mean, you heard about this from Mark Russinovich in the keynote, this week. And this is essentially the same thing that is running on-prem, except it is running in Azure, right? And you have the same capability in other providers such as Amazon or Rackspace or any of the other providers who provide a virtual machine capability, right? So if you can run SQL Server on premises, and if you have the ability to move it, again you're getting rid of the capital expenditure, right? You don't have to worry about managing that hardware, and it's 100% compatible. So I think that's one of the key value props. If it runs here, it'll run there. There is that guarantee that it's just the same SQL Server product you've loved. And it's the other key value prop of why you want to move from a private cloud to public cloud is this rapid provisioning. You don't have to go through a 6-month process or a 3-month process to provision a database staging environment. You go to the cloud, you saw it in the demo. I mean, literally like 5 minutes. You get a SQL Server running in a VM, and use it for dev test or use it for any specific type of uses that you have in mind. And then, the other end of the spectrum that SQL Server has an offering is the Windows Azure SQL database, previously called as SQL Azure. It went through a name change. And here, really, the value prop is massive scale. If you're thinking about hundreds of databases and you want to rapidly provision, you don't want to bother about managing a VM or hardware, that's what you want to look at. And then really, the difference between this and that, the SQL Server running in a virtual machine, whether it's private cloud or public cloud and platform as a service, is really that management at scale. It's a magnitude of scale more than what you would see in a private cloud, given the elasticity of Azure itself. So hopefully this makes sense. So other couple of things that I wanted to show before we kind of jump into the SQL Server capabilities. when you think about deployment models, what we've heard from customers and ourselves, in our own learnings is that there is primarily three options, right? You do it yourself, which is the first option, right? You go look up, you figure out what hardware works for your workload needs. You pick the software that you want, SQL Server, Hyper-V, VMware, whatever set that your organization thinks is important for you. And then you build it on your own, right? A lot of you likely are in this mode, right? You already have existing hardware. You don't want to go and buy new hardware. You have your refresh cycles, if you will, right? And, if you think about the three, like the criteria here, is it fastest in terms of time to solution? This is probably good because you already have existing hardware. You don't have to go through a purchase order to buy new hardware or have a new contract with Dell or HP or whichever OEM you work with. And the performance at scale, again, I think it's pretty good. I mean, we start at a point where everything is good, right? Because, you're moving from an environment where you had SQL Server sprawl. You were, over-provisioned the SQL Server. It was under-managed. You didn't even know you had a SQL Server. So this in itself is considerable gains, right? And the flexibility, of course, because you're doing it yourself, you're able to leverage what you already have. You have choice, much more choice than the other two options you'll see. The second option is what we call as reference architecture, and I don't know how many of you are familiar with this. Can I get a show of hands? How many have seen the Microsoft reference architecture? Okay, so just about 4. I would highly encourage you guys to take a look at this. This is a fantastic piece of work that there is a separate group in Microsoft that put together. It's completely agnostic. There is no selling Microsoft in this architecture. It's actually how do you build a private cloud? What are the practices, patterns? How do you bring together the technology stack and the service layer of servicing a private cloud? So I would highly encourage you guys to take a look at it, whether you end up choosing us or not, because it gives you a good framework of how you want to think about what are the concerns that you want to mitigate. And I think the reference architecture in simplicity is a bill of materials. It talks about what are the key components that you need if you had to build a private cloud on your own. So it's a little better than the self-service option in that you have some guidance coming from Microsoft. And we are building our own private clouds internally, and we are also selling appliances. So obviously, all those learnings is factored in here. So I'll highly, highly encourage you guys to take a look at it. I know there were a couple of sessions in TechEd Europe that talked about this. You guys can, if you haven't attended that, you can go back and access those videos. And in terms of time to solution, performance and scale, component flexibility, obviously, it's a notch above. The flexibility, obviously, you're giving up control. It's the same kind of spectrum. The last one is obviously appliance, right? You have several vendors, including Microsoft, working with OEMs to kind of provide this appliance, right? You have the Oracle Exadata or the Microsoft Private Cloud appliance. And the key here is it's turnkey, right? You go, it's optimized for a certain set of workloads. SQL Server has this appliance called SQL Server Microsoft Private Cloud Appliance. And this is optimized for database workloads, right? If you're running OLTP or if you're running BI, if you're running data warehousing, we've made sure we put tremendous efforts in configuring the hardware and the software to make sure it works good, right? So, really we think this is the fastest time to solution. Literally, it should be just, a couple of weeks for you to kind of get the box shipped and then get going. The performance obviously is super optimized. It can cater for densities, like database densities that, typically if you were doing it on your own, it requires a lot of work to get to that, database density. And obviously component flexibility, it's an appliance, you get what you get. So again, I think all three are options. You have to figure out what is best for your organization and your needs. And this can be a time framed decision. Maybe in the next 3 years you choose one. The 3 years after that you will choose something else, right? A couple of other things that I wanted to mention, and I'll promise that the next slide is SQL Server specific. So the two patterns that we've seen, when we talk to customers, even before SQL Server 2012, the two common deployment patterns that we constantly hear about is the centralized IT services pattern, and think of this as your mission critical application that's about to get virtualized, or maybe not the mission critical application, but a combination of many departmental applications that makes it mission critical, and where your IT department plays the role of making sure that there is uptime. You're optimizing for uptime here. So this is where all the great Windows Server and SQL Server technologies around HADR come into picture. And you do care about rapid deployment, because after all, that's one of the benefits of private cloud, right? Even from a SQL Server point of view. So they typically have these three attributes. There are centrally managed databases. They tend to run on larger VMs. and there is application level HA. In our case, it's SQL Server level HA, right? And here is an example of what that architecture looks like. And on your right, you have the self-service pattern, and this is your rapid deployment. I am a developer in my org. I want to have a self-service from my IT department where I can create a dev environment, do some stuff, tear it down, right? Now this is all focused on reducing this end-to-end provisioning time from months to weeks or even hours, right? And typically the characteristics here are you have like VM level templates that the IT department creates for you, and you also have just the VM level HA. Because you're doing dev test or you're doing staging type of work and non-production work, and obviously the value proposition is to optimize for solution. So does this sound reasonable? Is this something that you guys do as well? Is there an agreement in terms of these two patterns? Just a show of hands. Okay. Yeah, I mean what we've heard is it's not a either or. A lot of customers say what, I want both, and that's likely how it's going to be. But throughout the talk, we will talk about SQL Server capabilities, and I highlight, for which of the pattern you should think about using it. All right. So SQL Server Private Cloud, right? So when we think about what are the capabilities, there are 4 things that come to mind, and you heard this even in the keynote. This is no different than what you heard from Brad Anderson in the keynote. There are 4 characteristics of any cloud solution, and that applies to SQL Server Private Cloud as well. And those are essentially the 4 things: the scalability and elasticity. And what do we mean by that? It's the ability to kind of meet, this variable workload demands, right? SQL Server burst, you have an OLTP activity, suddenly in the night or in the, a seasonal activity around tax season, your expectation around concurrency doubles or triples, right? The ability to kind of meet those kind of workload demands is what we mean by scalable and elastic. And there is also this notion of, like pay as you go, consumption-based model. You only pay for what you use. Whether it's private or public cloud, it's again something that we think about as a characteristic of a private cloud. And obviously that all implies about making more efficient gains in terms of green IT. I have something, I want to get more out of what I have, right? So the idea of green IT is key here. The next dimension or the next attribute is shared resources. It's about multi-tenancy here, right? You have a whole bunch of resources: CPU, compute, memory, network. Can I treat that as a pool and then create this sense of isolation between individual tenants, right? Specifically for a SQL Server workload. You have an OLTP workload, you have a BI workload, you have a reporting workload. They have interesting resource consumption characteristics. How do you guarantee predictability for each one of those tenants, yet don't have redundant hardware, right? You don't want to give them a separate hardware, them a separate hardware. It's going to be so expensive. So the goal is to reduce that capital expenditure and also have this prioritization between different workloads. And the end result is to improve utilization. The third thing is always up and always on. This is about high availability, right? Private cloud is a consolidation of multiple single tenants and multiple single resources. So you're putting all your eggs in one basket. You don't want that thing to fall down, right? Because individually they may not be as valuable, but together, it's important for you, right? So that's the idea here. The extreme high availability and the low cost disaster recovery, making this a strategic move for your IT department. All right, and the last option is obviously with all this private cloud, you want automation built in, right? The notion of self-service, because operational expenditure, when you put multiple things in a single environment, you don't want that to multiply it by 10x or 100x, right? So automation is key, because at the end of the day, what you want is the time to solution. You want to be able to kind of go from 0 to 60 and continuously improve on it. And we'll talk about some of the capabilities here. So I'll go through each one of these pillars and talk about what specifically we did in SQL Server 2012 and how you can use and leverage it in a private cloud environment. You guys have seen all the details on the Windows Server 2012. You've seen the details on System Center SP1. So I'm not going to talk about that. We'll just focus on the SQL Server capabilities. So hopefully in combination, you'd be able to build a pretty compelling private cloud solution. So in terms of scalable and elastic as an attribute, we talked about what that means. And in SQL Server 2012, there are 3 things that I want to highlight, right? The first is the support for dynamic memory. We'll talk about what that means. The second thing is the SQL Server database engine, the relational database engine. We re-architected the memory manager specifically for helping out some of the use cases for private cloud, and you'll see what that is. And then the scale up. Today VMs are getting much bigger. You saw again in the keynote, the VM was running 64 virtual cores. I mean, just 2 years ago, we couldn't even fathom that, you could actually have such a big VM. But, we are there today. So we'll talk about, how you can leverage some of these capabilities. All right, so dynamic memory, what is it? So dynamic memory is a Hyper-V feature that was introduced in Windows Server 2008 R2 SP1. It's quite a mouthful. So the previous version to Windows Server 2012 introduced this feature called dynamic memory. And in essence, all it does is enable this VM to be elastic. Instead of saying, hey, I'm creating a VM, it gets like, 100 megs of RAM or, 24 gigs of RAM. Essentially you have the ability to kind of specify a min and max, so it can grow and shrink as you need. And the idea behind this is it reduces the VM configuration complexity. You don't have to be precise. You know that your workload can expand and shrink, and the VM can expand and shrink along with it. And in essence, essentially, this is implementing elasticity, right? So in terms of SQL Server, one of the things that have changed in the previous releases versus 2012 is the support for non-enterprise queues. This was a top customer ask to Microsoft to be able to allow this, especially in a VM environment, in a virtualization environment. You want to kind of create this ability to scale and be elastic. So in SQL Server 2012, only in 64-bit, you'll be able to use this whether you're using enterprise, standard, or a web SKU. And to show more of dynamic memory in action, I'll ask Guy to take a look at it. But this is a great feature if you're thinking about the self-service pattern, where I just want to rapidly provision, and I don't really know how much my workload is going to use because I'm doing dev test. This is perfect because you can expand and shrink and thereby fit in more and more such VMs, if you will. I'll hand over to Guy so he can talk about this.
Okay, thanks, Madan.
Yeah.
Maybe I can start by asking, most of you said that you're virtualizing SQL Server. Do any of you use any kind of dynamic memory, whether that's VMware ballooning or the Hyper-V dynamic memory? Okay, not too many. Does anyone think that sounds like a really bad idea, running SQL Server in a dynamic memory environment? I've heard that said. I think DBAs can be a bit nervous about that, and I think it's fair to say if you've got all the memory that you need, maybe you don't need to worry about dynamic memory. But I'm going to take a look at how SQL Server runs in a varying memory environment, and perhaps look at some circumstances where it could be very useful. As we said, that SQL Server supports dynamic memory, so let's see how that actually works. I'm going to zoom my screen. What you see here is my private cloud, which is running on this laptop. And these are the virtual machines running on it. And this is the machine that we're going to look at. Can you see that okay? So this is the rep SRV NY. Currently, it's got an assigned memory of about 1.2 GB. The CPU's not really doing anything. It's a very inactive machine. I'm going to look at the settings for this and click on memory, and let's zoom again. So we can see that it's set to have a startup RAM of 1 GB and a maximum RAM of 3 GB. So let's go look at the SQL Server instance and maybe do some work and see if this memory can vary. So I'm logged onto this VM, and I've got this fun-looking query here, which all it's really doing is it's kind of doing a report of the memory state. So let's run that. So if we look at this, so I've queried some of the DMVs, DMOS sysinfo, DMOS sysmemory, and it's reporting on the physical. I'm pointing to my laptop, and nobody can see me pointing, but it's pointing to the physical memory on the machine. It's in the DMV. It detects that it's running on a hypervisor, and currently it's got the high memory signal. What that means is that the OS is not reporting that it's running low on memory. And also I'm looking at the memory brokers and just seeing how much memory is committed there. So that's the current state, 1.2 GB. So now I'm going to run a workload. This is not a particularly inspiring workload. It's just going to go around in a loop and do lots of inserts. So let's run that and see what happens. Okay, so it's in the loop. Now let's run the memory again. And it's already started going up, the physical memory, and the allocations per second are now, there's about 278 KB being allocated per second. I'll run this again. And now physical memory is up to about 1.5 GB. And so what this means is that as SQL Server starts allocating memory, the operating system starts running low on memory, and then it hot adds more memory. So as far as the operating system is concerned, it looks like someone's physically added more memory. And that's what we mean by SQL Server supporting this. SQL Server checks for how much memory is on the system every second or so, and then if it finds more, it uses more. So I'll just run it once more. And now it's up to 2 GB. So the memory is growing on this VM because we're doing work on it. So that's all very well. I think any DBAs accept the fact that SQL Server likes to grow. But does it like to give any memory back? I think that's where the doubt about dynamic memory can exist. So let's introduce a memory constraint. Let's suppose something rather unfortunate happened, and another host in our private cloud failed, and that caused a whole load of VMs to fail over to this host, suddenly really constraining memory. I'm going to simulate that by starting a VM, which is rather large compared to for this machine. So this machine, it's got a static RAM of 13 GB, and it's a 16 GB machine, and there's 2 VMs running already, so it's going to be a bit of a problem. So let's start this. And actually, let's just check. Currently, the VM that's doing the work is now up to its maximum of 3 GB. So let's just start this. So suddenly, it's started, and there's 13 GB added to the system. So now, the memory status is warning, and it's starting to cut back. So let's go back to our instance and see what's happening. So I'm going to run this status again. And it took a while to actually execute because it was running slowly. Now, let's zoom this. You see that it still thinks the physical memory is 3 GB because although memory gets added as like hot add memory, as if it's being physically added, it uses ballooning to reduce the memory. So it's like there's a device driver under there that's allocating memory and taking it away from the VM. But the low memory signal is now on. I'm pointing to my laptop again. The low memory signal is now on, so that means that SQL Server recognizes that there's a low memory situation, and it started deallocating, it started freeing memory from its buffers, so there's no more memory being allocated. In fact, let's run that memory status again, and as it goes on, it's going to start releasing memory. Yeah, the query is still running, but it's still managing to run the query okay. So what we've really simulated here is a situation where sometimes you're just forced to constrain memory. And then if that happens, one of the things I really like about SQL Server is the memory manager. It's very good at adapting to either a situation where there's available memory or a situation where memory is constrained, so it starts releasing it. So that's about it for this demo. I just really want to say if you can afford all the memory you could ever need, you may not need to use this, but if there are situations where you may want to fail over it, it could be very useful to just start with a small amount of memory and allow it to grow. It also helps in terms of sizing and figuring out how large should my VM be. Sometimes that's a very difficult question, and you don't really need to answer it if you're using dynamic memory.
Thanks, guys. So just to summarize Guy's points, right? So really the key value prop of this particular support, right, the support for dynamic memory, is to be able to kind of expand and shrink, right? Your workload based on real-time demands, and setting this max, the startup RAM and the maximum RAM, and even priorities in Hyper-V dynamic memory wizard allows you to do that, right? So here are some of the guidelines based on some of the testing that we've done, both internally as well as in working with customers. One of the things that you want to think about is, there is a parameter called startup RAM in dynamic memory. You want to set it to be at least 1 GB plus, if you're using SQL Server min memory, the min server memory, which is a SP configure option. You want to make sure that this math works out. Obviously, this is a guideline. You want to be able to test your own workload and make sure it works for you. And if you're using it for unplanned failover scenarios like what Guy simulated, you want to make sure that of all the virtual machines that are going to fail over to this host, you want to again make sure that the startup RAM is of all the VMs is not something unrealistic, right? And the maximum RAM is again another parameter that you have in dynamic memory, and you want to make sure that it is the greater than SQL Server max memory if set. Because what you're going to have is if you have SQL Server max server memory set to a larger value, you're going to get into some contention issues. And again, in this environment, when you're using dynamic memory, we encourage you to use SQL Server max server memory so you can be more predictable in terms of SQL Server workload consumption, especially if you're doing live migration. You want to do that so that you're helping the live migration process. You might as well kind of reduce the max server memory so the live migration actually succeeds. So something for you to think about. There is actually a white paper that we produced, and this was produced for SQL Server 2008 R2. We're going to have an update for SQL Server 2012. So I highly recommend for you guys to go take a look at it if you're interested in using this feature. And I also had some additional tips. These are some of the top performance counters that you want to look at. Again, you will have access to the deck, and if you have any questions, you can follow us offline. The next feature I wanted to talk about is the memory management. Guy hinted on that, and I hinted on that as well. So one of the big investments that we made in SQL Server 2012 is to re-architect the memory manager, and we did it for many reasons. One of the reasons is to make sure that SQL Server is forward-looking in terms of some of the hardware trends that we are seeing. What we are noticing in the industry is that memory is getting cheaper. It's getting more denser, right? Just few years ago, it was costly for you to install like a terabyte of RAM. Now a terabyte of RAM is literally something that you can afford in a commodity box. So in order to deal with such kind of high density memories at low cost, we re-architected the memory manager. And the key value prop, and it has a fancy details here, but really the key takeaway I would like to impart is it makes sizing SQL Server easier, right? That's really the bottom line, right? If you have used max server memory prior to SQL Server 2012, you would have noticed that when you set that max server memory size, it's not governing all SQL Server allocations in terms of memory. There were like allocations that are greater than 8K. I show this in the diagram, right? Anything that is above 8K, if you're doing a backup, for example, typically the memory allocations are bigger. Those weren't governed. Those were governed by what we called as multi-page allocations, right? If you're using CLR, right? Those weren't governed. If you're making direct Windows allocation, you wrote a store proc, you loaded an assembly that calls virtual alloc. So those kind of things were not governed. In SQL Server 2012, there is still a couple of things that we don't govern through maximum memory, but that is by far the least amount of allocations that happens in the SQL Server process space. But the fact that we can now control CLR allocations, the fact that you can control any other SQL Server memory allocations, what that means to you is you can do predictable planning in terms of capacity. Say you're running SQL Server in a virtual machine environment, and you're running multiple virtual machines, probably with SQL or something else, and you want to be able to kind of predictably say, oh, if I give this much memory to the VM, I'm not going to have a performance impact. So this will help you there. And just some guidelines in terms of sizing memory, especially in terms of memory, max server memory or min server memory. Definitely use max server memory if you're running SQL Server in a virtual machine. This is important because in a virtual machine environment, especially if you use things like dynamic memory, you want to be able to have a predictable SQL Server workload experience. Make sure that you leave enough room. This is the same best practice that you have on the physical box. It doesn't change. But definitely think about using max server memory. I don't know how many of you are using large pages. It's not a feature that people most commonly use. But if you're using that, definitely use max server memory. Same with min server memory. Make sure that you have enough. This is the minimum memory that will be guaranteed for SQL Server. Max memory is something that if the memory is available, you'll get it. So min server memory is again something that you can use to protect your SQL Server from not getting that memory. If you have looked into some of the details about Windows Server 2012, there is a book outside. There is this new feature called Virtual NUMA. And how many of you are aware of NUMA? Right. So this is becoming more and more common. NUMA is essentially non-uniform memory access, essentially a hardware architecture that allows you to optimize for memory that is co-located with the processor. So if you're doing processing with your database, you don't want to go cache on a far away cache, right? Because that's going to cause impact on your performance. So SQL Server since 2005 is NUMA aware. What that means is we take advantage of the fact that the hardware can support this, and we do intelligent things with scheduling and memory management. Now, what we have in Windows Server 2012 is within a virtual machine, we have that concept, the virtual NUMA. And what that allows you to do is, be very performant, within a virtual machine, whether you're running SQL Server or any other application. So the same best practices around NUMA applies here. Make sure that, if you're affinitizing cores, CPU affinity, you want to do it in a fashion that the affinity for the CPU as well as the memory management is aligned within a NUMA boundary. I'll keep going here. In terms of scale up, you heard about this in the keynote. So Windows Server 2012 will support 640 logical processors. I mean, literally, there is probably no mission critical system that cannot run on such big machines, right? So some of our OEM partners, such as HP and IBM, they're building such big machines that you can either, run virtual machines on top of them or run natively, right? There are workloads that need that. So, in terms of scale up, SQL Server partnered up with Windows Server to make sure that on such big machines, the database workloads would also run in a performant way and can scale. Specifically for your private cloud, if you're thinking about virtualization, here are the new limits, right? And you can see between Windows Server 2008 R2 and Windows Server 2012, even though this is just the release candidate, the improvement factor is significant. In some cases, it's 16x or more, right? The couple of things that I would like to point out is, the fact that, your biggest virtual machine is 64 virtual processors. I mean, literally, you shouldn't hesitate anymore about, performance within these virtual machines. A lot of good work happened between, SQL Server teams and Windows Server. And again, you saw this demo, like 1 million IOPS, this is something that, we wouldn't have even imagined. Just the combination of the hardware bleed as well as the software changes is enabling us to get this kind of performance. And again, this is a great feature for you to think about if you're thinking about large VMs running mission critical system, which is the centralized IT services pattern. So let me transition to the next pillar. So the next pillar is really about shared resources. In other words, multi-tenancy, right? You have multiple VMs running in a private cloud environment, or you have a large VM. You have 32 virtual processors or 64 virtual processors, and you have a big SQL Server instance running in it. And you want like multi-instance within the SQL Server, right? Like you have multiple workloads running in it. We made a lot of enhancements in Resource Governor. And before I go further, so how many of you are aware of Resource Governor? How many of you use Resource Governor? Okay. And so this, if you haven't given it a try, this is probably the best time for you to, use that, because we've addressed some of the top customer asks in this area as well. The two things that I would like to call out is the fact that in Resource Governor in SQL Server 2008 R2 or before, we were only supporting up to 20 tenants, meaning like you can only create 20 resource pools and 20 workload groups. Now we have moved that to 64 resource pools, and this again is because of the virtualization demand, if you will. We also have implemented the ability to kind of do a max cap, especially to kind of create this predictability in terms of chargeback. You have multiple tenants running within SQL Server instance in a VM, and you want to be able to predictably say, you will only get this much CPU and no more, right? So that's something you want to think about. We also have another feature called pool affinity, where you can actually bind resource pools like CPU memory to a particular set of schedulers or physical logical processors, if you will. Again, I'll ask a guy to give a demo of this, and this is a great feature that you should think about if you are thinking about a centralized IT pattern.
Okay, so this is a nice summary of how the resource governor works. At the bottom, you start with resource pools. So with these pools, the green ones are effectively user pools, and you can configure those how you like. So you can say, I want this percentage of the machine's CPU resources, I want this percentage of the machine's memory resources, and you can set a minimum, like I always want to get this much. You can set a maximum, say if there's contention for resources, try and give me this much, but then if there are resources available, I still want 100%. And now you can set a cap, saying don't give me any more than this, which can be useful for chargeback, for example, and predictable billing. There's also an internal pool, the system pool, so the system gets whatever resources it needs for its internal operations. So that's basically how you can divide the machine. Then you can assign one or more workload groups to each pool. And the way workloads get classified into this is a classifier function which you can write yourself. So then you can filter incoming connections based on anything you want. For example, the incoming username, the database name, and there's a whole host of other parameters you can filter on. So connection requests come in, the classifier checks the attributes and then filters it into a workload group, which then is then associated with a pool. So that way you can isolate the workloads and assign whatever resources you like. So let's look at that in action. So let's suppose you're running a centralized database service in your private cloud, and there's two departments that are using the same database, let's say sales and marketing. You do internal charging for resources. The sales department always want the resources that they need. So if possible, they would be happy with 100% of the resources. The marketing department, they have low priority queries and they have a fixed budget as well. So they actually would prefer predictable billing and they don't necessarily need 100% of the resources. So your job is to provide workload isolation and predictable performance for these two workloads that are effectively running against the same instance. So I've got a script here which I'm going to create the basic logins and create a workload. I've deliberately created a workload that just does CPU. It's a very CPU intensive workload so that I can then, I've got kind of a clean environment to show how it's working. So I'll start by doing this initial setup. I create the logins for sales and marketing, and then I create the procedure that does the work. The other thing I'm going to do is, for the initial part of the demo, I'm just going to affinitize SQL Server to a single CPU, because I want to show that problem when they're competing. And I guess you can imagine this in a much larger environment where you've got multiple workloads and more workloads than CPUs. So let's run that. Then I'm going to create the workload groups and resource pools and the classifier function, which sorts just on the login. So if it's a sales user, it's going to go to the sales workload group, which is associated with the sales resource pool. However, I'm not going to configure Resource Governor. First, I'm going to show what it's like with it unconfigured. So I'm going to create them, but I'm not going to configure them. And that lets us view them by pool, but see how they are before we do any configuring. So that's set up. So now let's start the workloads. I've got a performance monitor here. And these little programs, they just run that workload. So one logs on as sales, and the other one I'm going to change to marketing. So I'll start the sales. And what it does is it does a count of how many times it has. Can you see it okay? It does a count of how many times it's running the procedure, and it also does a count of the rate every 5 seconds, how many times it runs the procedure. Now, ignore the fact that the CPU monitor goes up to 50. That's because this VM has 2 CPUs, but I've affinitized SQL Server to a single CPU. So where you see 50, it's really 100% of the CPU. That's why I've made the top of the graph 50. So rather just look at where it is in relation to the graph. And as you might expect, if we just run the one workload, it's happily using 100% of CPU, so sales are getting what they want. If I start the other workload, let's move these. Then, as we might expect, it's the same workload, so they're competing for resources, so the lines are kind of waving around halfway. Is it clear at the back? Okay, good. Sorry?
No.
It is? Good. Okay. All right, so that's not a good situation for sales, so let's see if we can do something about this. So the first thing I'm going to do is I'm going to alter the sales pool and set a minimum CPU % of 70. Let's see if we can give them a higher priority that way. So I'll go back to my monitor. This line's split up now. It doesn't really look like they're getting 70%, though. It looks like they're getting maybe between 50 and 60%. And that's because with one scheduler and two workloads that are using 100% of CPU, it's actually quite difficult to divide it 30-70. The scheduler has certain quanta that it uses, like 4 millisecond quanta, and it can't necessarily do that even distribution when you've just got one CPU. So let's see if we can, perhaps we can use a new feature in SQL Server 2012, which is the cap CPU %. So instead of just opportunistically using whatever CPU it can, we're now going to cap the marketing pool at 30%. So let's try that. And now these lines diverge more like you would expect. So the sales CPU usage is close to 70%, and the marketing is now capped at 30%. But we're still not really giving sales. Sales would really like 100% in this situation. So perhaps what I'll do here is I'll stop these workloads. And I'll go back to finitizing the VM to 2 CPUs. What I'm going to do then is affinitize these resource pools. So this is another SQL Server 2012 feature, which lets you affinitize a resource pool to a specific scheduler. So I'm going to affinitize these 2 resource pools to 2 schedulers, which effectively is giving them their own CPU. So I'll run that. And then let's run these workloads again. So when it's running this, we now see that on one CPU it's getting 100%, and on the other CPU it's getting 30%. So it's capped. So now marketing has the predictable billing, and sales are getting 100%. So this is really giving you the opportunity to kind of vertically carve up your machine. And you've got quite a lot of flexibility with that 3-layer method of having resource pools, multiple workload groups, and the classifier function. So it's a lot of flexibility, and it's really good if you need to provide isolation for workloads and predictable performance. Okay, you can hand over.
Good. So I think the key point here is, you have a multi-tenant environment. They have various workloads with varying needs, and these are all tools for you to kind of slice and dice up your resources and create that pool that is predictable for each of these workloads. You will have different priorities between them, but you need these fine-grained tools to be able to construct a solution that works for you. And this works in whether it's a large VM, whether you're running it natively in the box, whatever your private cloud solution is, right? It doesn't matter, whether you're working on Hyper-V or VMware. These are tools that you could use today, right? SQL Server 2012. All right, so in terms of best practices, we've been doing a lot of work in this area, both from a public cloud point of view as well as private cloud, especially in our work with the SQL Server appliance. So definitely, think about using resource governor and larger VMs, especially in a private cloud environment. The first thing that you want to think about in a multi-tenant environment is to provide this sense of SLA for each workload, resource level predictability, predictable performance. And I think to extend that concept, it also goes beyond just a SQL Server instance running in a VM. Even VM templates, when you're provisioning VMs, you want to think about creating this tier of resource consumption. There is a small, medium, large, how many CPU you're giving, how much compute, how much memory, how much network, something for you to think about. And overcommitting, this is a question that we get from customers all the time. Hey, should I overcommit resources, right? Yes, you can, as long as you know that this is not going to impact your workload, SQL Server performance negatively, right? You have different types of SQL Server workloads: read-only workloads, CPU-intensive workloads, memory workloads, memory-intensive workloads. So when you're overcommitting a particular resource dimension, make sure that that particular resource is not intensive in your SQL Server performance, right? If you have like a really memory-intensive workload, maybe you can stretch the CPU resources and overcommit them, right? So think about the trade-offs there. And almost always, SQL Server is a memory-hungry application. If you want, better bang for the buck, if you will, you want to invest in more physical memory. Whether you're running in a physical machine or a virtual machine, it never goes wrong if you invest in more memory, more physical memory. Especially with cheaper rates for physical memory, this is something that you can easily get 2x or 3x more performance, for the money that you spend. Instead of going and tuning all the workload, maybe this is the first thing that you want to think about. The last three things is really about, in a virtualization environment, especially in a private cloud, most of the optimizations you do for a traditional physical machine, one thing you want to think about is in a consolidation environment where maybe traditionally you optimize for sequential I/O. Maybe you have an OLAP workload, analysis services. But if you're running in a VM and your disks are being consolidated, you have a single disk drive or a LUN that is basically servicing 2 VMs, each having SQL Server, it ends up becoming a random I/O as opposed to a sequential I/O. So think about optimizing for random I/O, especially in a private cloud environment. And again, displacement. You may be optimizing for disk placement so that SQL Server is close to accessing the data, but in a virtualized environment, you don't know how they are going to be used, right? So again, something for you to think about. Some of the box or the physical machine best practices may not just transfer directly. And again, the other learning that we've had is, we've always talked about fixed VHD as an option whenever you're using SQL Server in a virtual machine. In the last year, we found out actually dynamic VHD is better unless you have a really slow I/O subsystem. If you have a really good I/O subsystem, if you're using SAMs, you would probably want to think about using dynamic VHD because we found out that actually this helps in terms of the mobility, app mobility, and a bunch of other reasons as well. You've heard about SQL Server, Windows Server 2012. There is this new format called VHDX. This is something that we're really excited about from a SQL Server point of view because of the larger capacity that it can support. Up to 64 terabytes, as well as additional performance and fault tolerance investigations, if you will. I'll keep moving. So the next dimension is the always up, always on. The ability to kind of keep SQL Server and the private cloud up, right? You're running, especially for a centralized managed service IT pattern. You want this capability. You want that guarantee to say that my machine or my private cloud would never go down, right? And you've heard about it. There were several sessions in TechEd, over the past few days that was talking about always on. How many of you are aware of always on? Show of hands. Okay, so this is good. So this is our flagship, SQL Server HA solution for 2012, and a forward-looking as well. And it applies really well for private cloud environment, right? You've heard about it quite a bit, so I won't delve into details. But the key concept, there were two key concepts that were introduced. This concept of availability group. An availability group is essentially just a combination of databases, right? And it fits very well in a consolidation environment because you're no longer dealing with a single SQL instance or a single database. You're doing actions, whether it's high availability, it's application centric. You're running your application private cloud, it uses 2 or 3 databases, maybe more, and being able to create that availability group and being able to guarantee high availability at that level is really, really relevant here. And now we also introduced this idea of multiple secondaries, right? So you can have multiple availability groups and you can read from them, you can do backups from them, again, getting more out of your money, if you will. And in terms of, as part of the always on, some of the less talked about features is very important in a private cloud context. The thing that I would talk about is the clustering support for, the stretch clusters, as we call it, the multi-subnet support. This is again about, making DR cheaper for you, just based on a clustering solution. And a couple other things that I don't know if you guys heard about this. There is a new stored procedure called SP Server Diagnostics. I have a slide on that. And essentially, for the first time, you can get comprehensive health information about your SQL Server across all the components, whether you're using query processing, your SQL OS memory management. This is a very simple service stored procedure that will kind of give you a snapshot of what the system health is. And this is collected automatically for you as part of the default health information from SQL Server. And we also have additional support for hardware related RAS capabilities, hardware recoverability capabilities, specifically around memory errors, right? If you look at the data from all our data centers, the number one reason is disks failing. That is the most common error. But the number two reason is memory failures, right? You have your physical memory, it's 1 terabytes of memory. Something happens and it gets corrupted, right? Electrical imbalance or whatnot. Your whole SQL Server instance, dies, right? So in order to kind of protect yourself, we have built-in capability within SQL Server, and this is available in all SKUs. As long as you're running on a machine that supports it, we will actually recover a memory page and actually have SQL Server continuously run. Again, this is great for the centralized IT pattern, if you will. I want to talk about a couple of case studies. You might have seen this, in the always on, but it's very relevant in a Hyper-V environment, and that's the reason I showed here. And this is from Care Group. They've been working with us for the last year, working as part of the always on TAP program. And what they have here is a primary solution as well as a DR solution with always on. And what they've got is essentially a host cluster as well as a guest cluster. So they got two Denali servers that are host clustered on the top. They're running Windows Server 2008 R2. And they also have guest clustering, which is SQL Server running in the VM or clustered at the guest level. And you can also see that they have a DR side, and then the guest cluster extends over the DR side, thanks to the support from the Windows Server clustering team to have stretch clusters or multi-subnet clusters, right? So this, obviously, the host cluster protects you from hardware and OS protection, right? If anything happens at that level, SQL Server will continue to run. Now, the guest cluster, the protection it gives is OS and the guest OS and the SQL level protection, right? Whatever happens in the VM, you are protected at that level. And then you have availability group, essentially, configured on top of it. So these are actually in the same availability group, and that gives you the synchronous and asynchronous capabilities, right? So like we talked about, groups of databases, and that gives you the disk and DB failure protection. So literally, you have at the machine level, the VM level, individual databases level. So essentially, this is an extreme high availability solution. And again, an example of how you can mix and match SQL Server HA technologies with the guest, the virtualization technologies, right? And they go hand in hand, really. So when you think about implementing a solution over virtualization in a private cloud environment, think about how you can leverage the best of all worlds. And on top of it, they again use the Hyper-V live migration capability, and especially in Windows Server 2012, you can use storage migration as well to add, if you think about the previous slide, it's really about dealing with unplanned failover. Something happened in my hardware. Now, if you have planned failover, you're doing updates to your software, OS or guest, live migration comes in handy. They set up a live migration because they already have the host cluster. They don't have to do anything more. And they are able to kind of, do the kick off the live migration where they are able to kind of transfer memory content, and the application just, directly connects to the live migrated VM without any downtime. So this is a great solution for planned failover scenarios. So both unplanned failover as well as planned failover, with a combination of, these different technologies, you are able to kind of create the best of both worlds and an extreme high available solution. Really, I think so. In terms of best practices, think about, especially for the self-service pattern where you're optimizing for rapid deployment, think about live migration as a HA solution. In Windows Server 2012 as well as in System Center, you can create these as highly available VM templates that you can say, I don't need any SQL HA. All I need is this VM to be automatically live migrated if something happened. And in terms of the centralized IT service pattern, you want to, just like the example here with Care Group, you can mix and match these things. I'll keep going. SP server diagnostics, I said I'll talk about a little bit. So again, this is a built-in stored procedure that comes with every SQL Server instance that you can run, and it polls the system health, the SQL Server instance health every few minutes or every few seconds. And you can see the different failure conditions, right? 0 is where there is no automatic failover or restart, and it'll basically just have the error logs. It'll be monitoring all these different components and give you these error conditions, which you can then act on. If you have System Center or if you have Tivoli, you would be able to act on this and do certain actions so you can correct them, right? Again, I think this is so reliable that even if nothing else is working, right? Like if you remember in SQL Server, we have this idea of DAC connection, direct admin connection, where the resources that are needed for troubleshooting is guaranteed. Regardless of what your workload is doing or something else happening, you'll be guaranteed to be able to connect to the SQL Server instance and troubleshoot. And this is something similar. We've guaranteed that this store procedure can run regardless of the system state, right? So this is something that you want to think about, especially in a big, like a larger VM type environment. All right, the last pillar is automation and self-service. Obviously, in a private cloud, you're dealing with massive scale, and you want to reduce your OpEx as opposed to just multiplying it by how many other VMs that you have. And I think our approach has been in terms of investing more and more in PowerShell. A couple of releases, before SQL Server 2012, we started this journey in making sure that SQL Server is, treating PowerShell as a first-class citizen, and we made a lot of ground here. And if you see in 2012, we've made several additions in the SQL Server provider for all of the features that we made in SQL Server 2012, the flagship features, which includes analysis services support, the engine that supports Power View, the integration services, which is now a server in SQL Server. Again, it has support for PowerShell and X events. Any kind of troubleshooting that you can do in the database engine, now we have a PowerShell mechanism for it. And also the new scenarios that we enable, whether it's always on, it's end-to-end automatable using PowerShell. Anything that you can do in the always-on visit, which I think Guy will show, you should be able to kind of script it out. And the key thing here is, yes, you can go through the visit for one VM or two VMs, right? But if you're doing it for like hundreds of VMs, you really want a scriptable solution that you can actually execute at will. So I'll hand over to Guy again so he can quickly show the capabilities here.
Thanks, Madan. So suppose you want to automate your operations, including backup operations with PowerShell commandlets. In SQL 2012, we actually added 40 task-based commandlets. So when I say task-based, I mean instead of trying to figure out the SMO object model, you can say, I want to back up, I want to restore. So these commandlets make using PowerShell with SQL Server a lot easier. So you can just right-click on a database and you can go start PowerShell. I started this one because I wanted to change the size. So let's suppose I want to back up a database. I know I've looked at the list of new commandlets, and I know that the command is backup SQL database, but I don't know how to use it. So I'm going to say get help backup SQL database. And it comes back with a help. And perhaps I want some examples, so I can say examples. So I read this, and then that helps me figure out how to use it. So assuming that I can type correctly, I'll try backing up my demo database. So the database is DemoDB. I'll specify a backup file. And I'll hit enter. And amazingly, I typed it correctly. So it's backing up my demo database. And it should just, yep, you saw something flash on the screen. It just completed. Now I'm going to go back into SSMS, and I'm going to, delete this database. So now I've lost it, so I want to restore. So similarly, I can do get help restore SQL database. Gives me the help, so I'll try doing a restore. So the restore operation, you specify a server instance. So this is my server, the repsrv-ny. I specify a database. And I specify the backup file. and it's restored. So hopefully I can come here and I can click refresh and my database is back. That's a fairly uninteresting demo, but that's partly the point, that it's about automation, and it makes these operations very easy, and with the new commandlets, they're kind of task-based. Now, I don't really have time to set up an always-on availability group, but for example, if I go into the new availability group wizard, everything I can do in this wizard, I can do with a simple set of PowerShell commandlets. So it becomes very powerful, and there's some good tutorials if you search to completely automate this with PowerShell. So that's pretty much it.
Right. Thanks, Guy. So we've got about 10 minutes. So let me cover probably the most interesting topic, you have had questions about. So SQL Server 2012 licensing has changed. How many of you know about this? Okay. So there is actually a pretty good, usually, I get frustrated with some of the licensing documentation myself, but, this time around, I think they've done a better job than previous years. And you can just go to this link again, you can get access to this deck and you can click on that. And I captured, I basically took just the portions that are relevant for SQL Server running in a virtual machine environment, right? The first thing you want to know is, there are certain SKUs that are being charged in a core-based way, right? So they are charged for a CPU core, and that specifically is enterprise. Enterprise is actually offered only in core-based licenses. It's no longer offered in ServerCal. Business intelligence is offered only in ServerCal. Don't ask me why. And standard is offered in both. So one of the things that you want to kind of figure out is, okay, how do I figure out how much, what is my license obligation to Microsoft when I run in a VM, right? So there's two scenarios. You can either, license through individual core licenses per VM, or, we have this option, especially in a SQL Server private cloud environment, you basically get, software assurance where you get unlimited VMs. So we'll talk about both of this, right? The first scenario where you want to kind of just buy the core licenses that you need for a given VM, the minimum is 4 core licenses. And it works out in such a way, I don't know if you've seen this document, they actually have the core prices as well. It actually works out to be the same price that you would pay for a single core in a 4-socket server, right? So if you have 4 cores in your processor, the price approximately works to be the same, whether you buy it at the physical processor level or the core level, if you will. So the idea is, if you have a VM1 with 4 virtual cores, you need 4 core licenses. If you have one with 6, you need 6. It's pretty simple. But there is a minimum. Now, the minimum is what you want to be aware of. You have to get at least 4 or more, which then is something that you want to figure out in terms of how you size your VMs, if you will. And if you're using, say, the BI SKU, and you have to use server plus cal, the way it works is, you buy for the server, the virtual machine server, and you have to buy as many cals as needed. In this case, there is 3 people who are using it, so you need 3 cal licenses, if you will. If you look at the other scenario, which is for a private cloud, like we said, the thing that we would recommend is license all the physical cores. So, you don't have to worry about, how many VMs can I have, how many cores per VM. It just gives you all the flexibility. In this example, you can actually see this is basically a 2 physical processor server with 6 cores each. So you have basically 12 cores. And, if you have, if you license the physical processor, then you can run as many VMs as you want. In fact, in this example, we have 6 VMs each with 4 virtual cores. So essentially, you're overcommitting your CPU. But it doesn't matter. You've licensed the physical core that allows you that flexibility to do what you want with the VMs. And that's what you want in a private cloud environment, because you're going to grow and shrink, right? So you don't want to be like constantly thinking about, if I do this, what's my licensing obligation, right? So something for you to think about. Highly recommend you to go look at this, and give us feedback if it's not clear, right? We want to continuously iterate on this. So, all right. So last bit, this is a sales pitch, I guess. So this is from our marketing team. So case studies, this is the whole point of the slide from my point of view is, this is real. People are using SQL Server 2012 in a private cloud environment. Even though it's just been 3 months, we already have several customers who are using it and gaining value. And this is not to say that it's just SQL Server running on Hyper-V. Any private cloud environment that you have, there is a set of capabilities that we provided that should work, right? And that's what we talked about so far. And you can see the codes, right? This enables them, the best of both worlds. If you want like a centralized mission-critical IT private cloud environment, you can do that with SQL Server. Or if you want like live migration capabilities, which are suited for a self-service pattern, you can do that as well. And you can mix them match. So the key takeaway is, this is real. People are using it, and we have an increasing set of customers. And this is our appliance slide. So, again, I think our appliance offering essentially embeds all the best practices that I talked about. We put all the best practices that we've learned from customers, that we heard from customers, into our own appliance. And essentially, it comes in different form factors, and you can increase and decrease as you need. And you can see the density that we can support. I mean, this is one of the key investments that we made, that you can have 100 to 200 VMs, each possibly running SQL Server or something else that you want. And depending on the size of your operations, you're able to invest. Maybe you start small, you try it out, and you figure it out, and then you can expand. And this is from some of our early TAP customers in terms of what gains that they're seeing. In the first year, that they're seeing 35% more gains. Obviously, your mileage varies with how you're using this, but this is the information I got from the appliance team. For something for you guys to think about. This might be an option for you in certain cases. So just road ahead, I mean, we have a really good product with SQL Server 2012. We're very happy about the feedback that we're getting. Hopefully, you were able to gain some insight into the private cloud specific capabilities. But we are actually also super excited about Windows Server 2012. Right? Windows Server 2012 has a whole bunch of features, a few that I'm calling out, that are so relevant to SQL Server that will unlock some of the capabilities that we put in already in SQL Server 2012. The things that I would like to highlight is the fiber channel within the VM. This has been something that SQL Server customers specifically have been asking in Hyper-V for a long time. It's finally coming in 2012. We have the ability to do parallel live migration, storage migration. Storage spaces, again, a great feature that allows a multi-tenant isolation, right? Ability to kind of have multiple storage pools. Offload data transfer, we saw a lot of demos on that, even in the keynote. And then the other thing that we'll actually talk about this later today in the same room is the public infrastructure as a service, right? The SQL Server running in a Windows Azure Virtual Machine. Our team was personally involved in doing this. And again, this is something that we are really, really excited about, because if you run in a VM, you should be able to run in a VM in the public cloud. That's the guarantee that we're able to kind of give. And it makes it very easy for you to try out Azure, right? And if you, for some reason, say, yeah, this works fine, I need some more time, you can bring it back. That's absolutely the full VHT mobility. We'll talk about it more at 1 p.m. Highly encourage you guys to attend as well. And here are some of the resources. We'll have the map toolkit, the private cloud page, where you should have linked to all the resources, some example of the automation, more details about the memory RAS support, and also the SQL OS team blog. We constantly update this with information specific to virtualization or scale up or any other topics that you saw. So, and you can actually ask us questions, on the blog. We are very active in answering them as well. And that's all I got. Thanks for attending, and we'll be hanging out here. If you have any more questions, we'll be happy to take it. Thank you.
Thank you.